Now that's the whole purpose of the respiratory system, is for that. Once these gases are absorbed into the body, into the bloodstream, they have to be transported. Right? So part of it is we're going to have to talk also a little bit about how are these gases transported. And you know it's transported in the blood. You're probably aware of the fact that hemoglobin has something to do with it, right? And hemoglobin is important for oxygen transport, but as we'll see, it's also vital, and red blood cells are vital for carbon dioxide transport. And because of the way carbon dioxide gets transported, because of the chemistry of it, it affects pH in the body. Okay. So we're going to look at that. There is something called a bicarbonate buffer that is produced, and that helps us maintain or resist acidic pH changes. And it's because of the way we transport carbon dioxide that occurs. I can't remember if have we had an occasion to see, I think we did, carbonic anhydrase yet in here? If you take carbon dioxide and water and put them together, you get carbonic acid. All my kind of classes run together, so I can't really remember if we've done that yet. But at any rate, we'll chat a little bit about that. And because of that chemistry, that affects your pH. So the respiratory system in humans, in mammals actually, is also used for acid-base balance. So we're going to see a connection here with acid-base balance and the urinary system, which also does acid-base balance for the body when we get to that on Friday. Because we are bringing inhaled external substances into the body through the respiratory system, right? When you inhale air, we have to have protective functions of the respiratory system as well. It's pretty straightforward. Remember the tonsils? The tonsils are there. They're the lymphatic tissue that samples air and will produce an immune response to a pathogen if it detects one in there. So it's kind of like lymph nodes, but all they're sampling air. So we have the tonsils that do that. And we also have mucus that is produced to help trap any particulate matter before it gets settled down into these microscopic alveoli. And remember, the epithelium of the trachea is that ciliated pseudostratified. Remember that? So it's got the cilia on it. They beat, and they're constantly moving that mucus layer up, away from the lower respiratory tract. And as soon as it gets to the larynx, it's going to mix with digestive substances, and then will be swallowed into the stomach, sterilized, and things like that. So we certainly have the protection as well. We won't talk too much about that because it's kind of, I just told you, that's it. Okay. Vocalization, again, we're not going to talk a lot about the physiology of vocalization, but this is a sort of secondary adaptation, if you will, for the respiratory system to allow for vocalization. Remember the vocal folds or the vocal cords in the larynx. When you exhale, air moves across those. And if you change the tension of them, you will change the pitch that they vibrate at, and it will allow for communication. Obviously, humans use vocal communication as a primary source of communication. We also certainly use facial expressions and things like that, but vocalization has become an adaptation that we can certainly use the respiratory system for. What we'll focus mostly on are ventilation and gas exchange. We'll talk briefly today about pH balance as we do some of the chemistry of the transport of carbon dioxide, and we'll tie that again in with acid-base balance when we talk about that with regard to the urinary system on Friday. Okay, so that's kind of our goal. So we really want to get an idea of what's the physiology of ventilation, what's the physiology of gas exchange and gas transport. So those are our three kind of biggies. Seem all right?